Okay, let's compile. So it's in the bank, and there is a class called negative mount exception. Right? So this has compiled. Okay, but now we need to make changes in the account class as well, right? So this is first creating our own exception class. We have defined it, and now we can use this in the account class, okay, to throw exceptions. Okay, so we go to the account class. Okay, so in the constructor, if someone is giving me opening balance as negative, right? So maybe, yeah, let's start with this. So if opening balance is less than 0, okay, yeah, what we can be doing is we'll say, okay, throw, sorry, okay, negative opening balance, okay, and what's the amount, or what is the opening balance? So if it is negative, yes, we are giving an error. Okay, so that's in the constructor. Fine. The constructor here is just invoking the other constructor. It is using this, so it will anyway go through the check. Okay, then let's see where it's. We have the deposit method. Oh, if you are trying to deposit a negative value, I'll be giving you an error. If amount provided is less than 0, we'll throw a new yeah. The message will be maybe you'll say negative deposit. Okay, and that's the amount. Okay. A similar thing being done with the withdraw method. Okay. Negative withdrawal, and that's the amount. Fine. So all methods, right, they should do a check whether the value is correct or not. Okay. So any other problems with this? Let's, if we compile, yeah, will it compile? Have you forgotten something? Okay, let's try compiling and then see what happens. So this we had compiled, but now we would like to compile account class. And oh, there are 3 errors. Read the error message. It says unreported exception, negative amount exception must be caught or declared to be thrown. Must be caught means oh, it must get handled, right? So your statement should result in a unchecked exception. Sorry, checked exception. Negative amount exception is a checked exception. So you can get rid of this error, by changing the definition of negative amount exception also. It is a checked exception. If I convert this into an unchecked, how can I convert it into an unchecked? By changing the inheritance. Okay, it's inheriting from exception. No, let me change it to runtime exception. And if I do this, it will become unchecked exception, and then that compiles. Okay, but we don't want it to be unchecked. This was just to show that, okay, the difference here is this. Throws is not mentioned, right? It's compulsory. Okay, so we actually want it to be a check one. So that's not the change you should be doing. Okay, then what's the change? What's the change? We need to mention throws. Okay, so yeah, we have put the throws here. Yeah, there are 3 errors which it has shown to us. So we can just first initially try to take care of those 3 errors. We have done it with the deposit and withdraw methods. Okay, fine. So yeah, we got 3 errors and we have changed them, right? Let's see now again. Oh, we still have error. The constructor here is showing an error. Okay. The constructor with 2 parameters. See now what has happened. See, earlier it didn't report this error. Okay. The reason now for the error is that this one is saying, oh, I'm thrown. What you are using here has a throws. It has a throws, and that must be mentioned. It has a throws for a checked exception. So you will need even for the constructor over here, the throws thing. Okay. So now if I compile, yes, the account.java will compile. Okay. Let's try compiling. What do you want to compile? Maybe you want to compile, instead of ban, let me go to the test account.java. Fine. What do you think? It will compile? This one gives us errors. Lot of them. Anytime I'm using a withdraw or anything, that's an error. Right? Because the main method here, okay, and you can see from here, the main method here, okay, is having a, fine, it doesn't mention a throws, right? So main is not mentioning a throws. Okay, so we can put throws for the main method, and then let's see. Okay, so test account.java, yes, it's all in test account.java. Wherever any place we have done a deposit or withdrawal or even calling the constructor, they are all resulting in errors. Okay, it is currently it's only showing for the deposit and withdraw methods, but let's see. So let's fix whatever errors it is giving to us. Oh, they all can be taken care with the. One thing I can put here is I'll say, okay, this has a throws for. I'm using statements which can result in a checked exception. Okay, let's compile again. What do you think? It will compile? I've taken care with the main method having a throws now. But now you can see the errors are with the subclasses of account. Currently, yes, it is showing for current account. Okay, let's check that. Okay, let's open this one. Okay, so current account.java, yes, what should be done? We have said new current account. When we call the construct of current account, the construct of current account says super, which has got a throws. The superclass constructor has a throws, so I'll need a throws here also. Okay, so we have a throws negative mode exception over here and also over here. Okay, also similarly, we will need a throws for withdraw method, right? Because we have used super.throws. Here is your super.throws, super.withdraw. Yeah. So this has a throw. What you are using is having a throw, and therefore you need a throw. Okay, so current account is fine. But what about savings account? So let's examine and correct this also. Okay. So in this class, yes, we have the constructors and they are calling the superclass constructor, which is having a throws. We will need a throws here also. Okay. So let's compile. Now compiling test account, and that's working. Okay, and if I run, yeah, so everything is working fine. So what's the difference? Of course, the code which we have written in test account has no failure condition yet, right? We can change some of the things to fail. So test account, let's introduce some failures. And that can be done by putting a negative value for deposit, withdraw, or in the constructor. So maybe AC1 is a current account object. AC1.withdraw is done somewhere, I believe. Yeah, we had done AC1.withdraw. Okay, here is AC1.withdraw, and by mistake, I'll do a negative value here. Okay, fine. Let's try a negative withdrawal. So line 41. So line 41 in main. Okay, main, which is in test.test account. Okay, let's compile. Let's run the code. Okay. Now you can see what's the output. The line where we have done a negative withdrawal, fine, you can see the output from here, okay, and from this place onwards, right? So this is the output, which is nothing but the output of print stack trace. So whenever it is doing a print stack trace, it's actually invoking a toString method, exception in thread main, and then the rest of it is nothing but the toString method of the exception of the throwable. So throwable toString says give the name of the class, so bank.negative_exception colon whatever is the message, fine, colon and then the message is withdrawal. Okay, and then we added comma negative amount colon and the negative amount value. Okay, but then following this with what? Fine, you can see this error was thrown from. So what was at the top of the stack at that time? Oh, it is the withdraw method of account class. Fine, because it was doing a super.withdraw. Fine. So when you create the line number 71 in account.java, if you want to see what is there in the line number 71 of account.java, you can see that in account.java, line number 71. Okay. Sorry. Oh, here is throw. This is where we have actually done a throw. Okay. So at this point, when we said new negative amount exception, the object of negative amount exception was created. It called the superclass constructor, and that in turn called fill in stack trace. So at that point, yes, fill in stack trace was done, and in the stack trace, what it has captured that yes, this is, so what has been captured? Okay, so this is being called from, oh, this is being called from where? Who called this? So this is line 71. Who called it? It's a current account Java withdraw method. You can see that 4 things, right? It's giving you the name of the class, bank.account is name of the class, dot withdraw, it's giving you the method name, fine, and then it says account.java, that's a file name, colon and the line number. Now those four pieces of information which is in stack trace, that's here. Each line has that information about the frame. So there were 3 frames in all. If you start from the bottommost, it's a main method, and in test_account.java line 41, invoking the withdraw method on current account object. Okay, and that's at line 24. So line 41 is this, and then line 24 is calling the line 71. So we can go from travel from bottom to up. I think that's a better option. So we can start from line 41 of test_account.java. You can see this test_account.java line number 41. Oh, here's the right. We have changed. This is where so it says from here you called withdraw method on. So AC1 is of type current account. So therefore go to the current account. Okay. In current account, what is the line number? Current account line number is 24. Okay, let's see what is line 24. Yeah. So line 24 is saying if not super.withdraw, right? This is super.withdraw. So this withdraw method is super.withdraw. So withdraw method of the account class. That amount has been passed on to the account withdraw method of account class. Okay. So go to the account class. Okay. And there it says line number 71. So this is that line number 71. Okay, so line 71 is this, right? Clear? So from this to this to this. So those are the 3 things in the runtime stack. So at the time the error object was created. Okay, so this is basically the output of print stack trace is like this. So if it is terminating, it is doing a print stack trace. Okay, and so creating a custom exception class, and to some extent, yes, we have used it. Fine. We'll continue tomorrow, and tomorrow we'll examine the exception handling mechanism. Okay, so we'll look at some keywords like try, catch, and finally. Okay, those are the 3 keywords which we'll be looking at. See, 2 keywords we have already covered. One is throw and other is throws. Okay, so there are 3 more keywords which we'll be covering. Fine, so that we'll do tomorrow. Yeah. Just to confirm, tomorrow there is Saturday or Monday? Oh, it's on Monday. Sorry, not on Saturday. So yeah, next we meet on Monday. Okay. Okay. So have a nice weekend, everyone. Yeah. See, we'll also see the mechanism how we can uh, handle the exceptions. Okay. So yeah. So today's agenda will be, yes, we'll continue more on the exceptions part, and we are not yet done with the exceptions. Okay. We'll look at what are the constructors and methods of the throwable class. Okay. And also there is a concept of exception chaining which was introduced in Java 1.4. Okay, so we'll see that also. Fine, what is this exception chaining about? And then yes, we'll see if we can pick up the topic on exception handling part also. Okay, fine. So first thing, fine, let's get started with throwable class, right? Any questions before that? Yeah, any questions so far related to any of the topics? And don't restrict to only the exception topic. And if you have any doubt, you have tried something from earlier code or anything, and you find something, and you can ask that. So any questions here?
Do we have any limit like each space? What if it gets fully occupied and all?
Okay. Yeah, heap can also see, it's both of them. Even heap can be full, even the runtime stack can also get full. Okay. So initially when you start the JVM, so normally whatever sizes are allocated for the heap and the runtime stack, both are quite sufficient. Okay, in most cases, yes. So yeah, but we have options. When you start your JVM, you can specify the heap size. Okay, and the size of the heap can be specified when you what is the maximum heap size you would you can afford, and the minimum heap size it must have. Okay, so you can change that in the command line arguments basically. So at command line, yes, you can specify. Those are some settings which you have to do. So for the JVM, yes, the size of the heap can be mentioned. Yeah. Okay. As far as the size of the runtime stack is concerned, it is quite good enough. Okay. In most cases, sometimes what can happen is if you try recursive, fine, if you have a recursive method and the level of recursion goes very high, because see, if in recursion what happens, the method is calling itself again and again till a condition is met, right? So the level of recursion, that's where the stack will keep on growing, because the method is calling itself, fine, and that is in turn again calling itself. So when it's a recursion, the stack can, the consumption of runtime stack will be high. Okay, the number of frames getting created will be very high. So that's the time when, yes, you have to be careful. So if you really have a need where this runtime stack size needs to be controlled by you, you want to take control of that, how much it should be. Okay, we do have that option, but not for the normal applications. It would be related to, actually it's related to multi-threading. Okay, that runtime stack actually will relate to multi-threading. Later when we look at the topic on threads, we'll find that yes, the runtime stack we were seeing yesterday. Okay, so that relates to a thread basically. So yes, in the thread, yes, it's possible when you create your own thread, it's possible for you to specify the size of the runtime stack.
Okay.
Okay. Fine. So yeah, any other questions? Okay, fine. Then let's proceed. Okay. Fine. Yesterday we saw about checked exceptions, unchecked exceptions. Fine. Is it clear what is the difference between checked and unchecked exceptions?
Yes, sir. The only thing is, I think we lost a connection in last 15-20 minutes.
Acha. Okay, actually, whenever you lose a connection, you can just ping me. Okay, so
Okay.
so I don't know, because here I'm on my screen, which is in the editor most of the time, right? Okay, so
Okay.
I'll not realize. Okay, okay, so yeah, so this statement, I don't know whether you could throws declarations compulsory. This, I think I had written this when you before it was disconnected. See, all these things I was mentioning. We have two kinds of exceptions checked. All exceptions in Java are checked except for subclasses of error and runtime exception. Okay. Throws declaration is compulsory for checked exceptions. That's the main difference. Okay. Throws is compulsory for checked exceptions. And in any method, we cannot use a statement. So this is important, okay, to understand the difference. In any method, we cannot use a statement which can result in a checked exception being thrown, which is not covered by the throws declaration of the method. Okay. And so what do you mean by this? Yeah. Okay. Fine. Let me try explaining here. Okay. Checked and unchecked. Given a exception class, how do we identify what is checked and unchecked? Oh, for that, yes, we know the inheritance hierarchy. From where is that exception class being inherited? So that decides whether it's a checked or unchecked. Okay, fine. But from the point of view of the language, right? When you write any method, okay, so you may be writing some method, maybe, okay, I can consider like this. Okay, okay, I think I'll show it in the runtime stack again. Maybe. Fine. Consider one method here. Okay, yeah, this is normally the main method. Okay. So this corresponds to the main method. Fine. And main method has invoked another method. Let's call this method as M1. Okay. So when we write our method, any method, even including the main method, okay, in a method we are specifying, for a method what do we specify? We specify a return type. Okay. We can specify a return type and we specify throws. Okay, important thing for us, we specify throws. Okay, and in throws you can have a comma separated list of class names, which are the exception classes. Okay, names of the exception classes. Okay, so throws is a declaration where you're giving all this, right? So we understand that in a method, when we have given a return type, we know the return statement will have to return expression of whatever is the return type. Okay, fine. And the throws here, okay, throws has to cover all the checked exceptions. That is the idea. Okay, in the throws, you cannot miss out on a checked exception. Maybe you are using some method, you are invoking M2 here. Okay, now when you invoke M2, right, we understand M2 will be on top of this. the method M2 has its own return type. This method has its own throws. Okay, the method has got its own throws declaration. Any declaration of throws here, and if that is using in this throws, if there is a checked exception, it may be an unchecked one, then just ignore it. If the throws has a unchecked exception, we can ignore it. But if there is some checked exception here, let's say there is a class E1, which is a checked exception over here, and it is mentioned in the throws. Okay, fine. So it has said throws. So now, if in M1, if I am saying I am using M2, see, currently I'm not looking at exception handling at all. So I have invoked M2 just like that, and not part of a exception handling mechanism at all. Okay. So I may not have written an explicit throw for E1. There's no throw statement anywhere in my method M1. Okay. But since you are using M2, a statement which says I might be giving you an exception of type E1. Fine. Therefore, for M1 also, the throws even will come. Fine. That method M1 says, oh, I am returning a particular value, but I will have a throws with E1. And since M2 is being invoked from main, okay, M2, the main method also needs a throws for E1. Okay. Fine. So in any method, fine, in any method, right, you cannot have a statement. So M2, invoking M2 is a statement which can result in a checked exception which is not covered by the throws. Even I'm assuming here's a checked exception. So since I'm calling M2, M2 has a checked exceptions, and therefore I'm having a statement which can result in a checked exception of E1. So clear, we understand this now? Yeah, E1 would, you are not using a throw statement. So this is, main is calling M1 here, not M2. Main is calling M1 and M1 is calling M2. M2 has a throws E1, right? Because M2 has a throws E1, it will become compulsory for M1, which is using M2, to have a throws. Also, main is using M1. Since M1 will have a throws, main will also have a throws. Okay. Of course, it's another. So if we have written the statement of invoking M1 in such a way that this will not result in a checked exception ever, okay, it's possible by using the exception handling mechanism. So if we use that exception handling mechanism, it would be possible that we will not be writing throws also. Okay, fine. But we'll come to that part later. For the time being, yes. So the statement here, what we have made is that you cannot use any statement which can result in a checked exception being thrown, right, which is not covered by the throws of the method. And so in any method, we cannot use a statement. Fine, is this clear? Okay. Okay, fine. Yeah. Fine, then we proceed. Okay. Okay, so now let's look at the next thing, which is about what are the methods in the throwable class and also the constructors of throwable. See, what does a throwable represent? Any object of throwable or a subclass of throwable? So any object of throwable or a subclass of throwable represents an error condition which occurred at runtime. Okay. Fine. So if there is an error condition, let's look at the constructors. Fine. So now we'll try looking at the constructors for which are available for okay, what are the constructors of throwable class? Okay. So here I am listing them. So one simple option is you can create a throwable object by specifying a string, a message, which is nothing but your error message. So this is one option. The most commonly used option is this. Okay. Another constructor of throwable is where we can say, okay, you can pass two things. You can say, okay, we have a message, but along with the message, okay, there is another throwable object being specified. Okay. So this is nothing but the cause of the exception. Right? We are there is an error, but this error is because of another error which occurred. Okay, this is what is useful in what we call as this is the constructor which is mainly used for exception chaining. Okay, fine. And we have then another constructor of throwable. Okay. Where you only specify the cause. Maybe you don't want to specify the message. And we still have another constructor throwable where maybe you don't pass even the message or anything. So default no argument constructor is also available. So these are the publicly available constructors for the throwable class. Okay. Fine. So throwable class constructors. So you want to create an object of throwable, you must have a message and you optionally can also have a cause. So two things are used mainly. Okay. Fine. So accordingly, that means we understand that anytime when you have a throwable object, it's possible for, so yeah, what kind of methods must be available then? We have a public method which returns a string called getMessage. And so it has provided a getMessage. Since it has taken a message as a parameter, yes, it has provided a getMessage. Another thing which we have is there's a method called getCause. Okay, what is the cause of this particular exception? Throwables are exceptions basically. Okay. Right. So these two methods are quite obvious. Yes, since it can have a so if you didn't specify a message, this would be null. If you didn't specify a cause, this would be null. Okay, fine. We don't have a method to change the message there. Fine. Also, if a cause has been specified, okay, if you have specified a cause while creating a throwable object, so while specifying, right? So while creating a throwable object, you have not specified a cause. It is possible for you to use this method called initCause. So this can be used for setting up the throwable object. If the cause has not been set on a throwable and you want to set up a cause, you can set it. Okay. So initCause will work only if the cause is null. Okay. Another object of another method here. Okay, fine. Now I'll mention a few methods. and we'll discuss them. Okay, so there is also a method called returns void. Name of the method is fill in stack trace. There's one method called fill in stack trace. There's another method which returns object of a class called array basically. So we have a class called stack trace element. An array of that is returned by a method called get stack trace. Okay, and we also have a method returns void print stack trace. Okay, fine. Let's try to understand these three methods basically. Okay, yeah, this is something which you need to understand first, maybe. Okay, so let's try to get what are these three methods like. Okay, okay. So maybe if we look at this diagram itself. Okay, fine. Someone created a, okay, yeah, just one more point which is related to the fill in stack trace method. Okay, okay. So this is always called from the constructor. So the constructor is calling this method. Okay. So this is something which is being done. Okay. So this is something which happens the first time a throwable object is created. Okay. So from within the constructor, this method is called. Let's try to understand what is the job of this method. And I think before that, I'll also put one more thing. We need to, I have introduced another class here called stack trace element. Right? So an array of stack trace element is created and available from an object of throwable. So throwable has basically three things available, right? You can see there are three things available in throwable. Three getter methods: get message, get cause, and the third get method is get stack trace. Okay, look at them. Oh, these are the methods to give me information about from a throwable object. So three things available from throwable. That's the way you can look at it. Message and cause, yes, we understand them fine. They are passed in the constructor and therefore the get method is available. But this method get stack trace works because we have the stack trace being created for us by the fill in stack trace method. So fill in stack trace method is actually creating an array of stack trace element. Okay, it is creating an array of stack trace element and setting it up in the object of throwable. So throwable object gets a stack trace because of invocation of fill in stack trace happening from the constructor. Okay, initially it happens from the constructor. Okay, fine. Let me first okay. So if you look, consider the stack trace element class. Okay, okay. What does this object of stack trace element actually represent? Okay. So come to this place. Let's see. Okay, fine. We understand that there is a runtime stack which is there. Okay, and in runtime stack we have a frame, right? We have a frame for each method which is currently active, currently executing, right? So main is there. Yes, it is from a particular class. This main is from a particular class. Method M1 is there. This is also from a particular class. So there are frames on the runtime stack, right? And these correspond to different these correspond to method. These methods belong to a different class. Okay, they may be belonging to different class, right? And so what we have is the stack trace element object, right? We have a stack trace element object corresponding to each frame. So a stack trace element object has information about a frame. Okay, so information corresponding to one frame, let's say. So if I consider one frame, what is the information we can gather about a frame? Okay. Right? So if we look at that information about a frame, okay, we can say, oh, this frame, okay, has a method name. So on a stack trace element, we have a method called get method name. So this is get method basically, yeah. So we have a method to return a name of the method. So for this, what's the method name? The method here is name. Okay, so one information about a frame is, oh, this is a frame corresponds to a method, so there is a method name. Okay, the method is has been defined inside a class, so we even have a class name for it. So there's a okay, what's the class name? Maybe it is if we consider yesterday's example, it is test rectangle. Okay, the one which has the main method. Okay, fine. So test rectangle is a class name. Okay, but this class has been defined in some Java file. Oh, what was that Java file name? It was test rectangle dot Java. So you have a file name. Okay, and another information which we have is it remembers the line number which it is currently executing, for corresponding to which we have, so some place it has invoked the method m1, so it has a line number. Okay, there is a line number in the Java file which it is currently executing. So 4 pieces of information for a frame. One frame, for that there are 4 pieces of information, and corresponding to these we have the 4 methods. Okay, there are 4 methods in the stack trace element class. Okay, so we have a class called stack trace element. Okay, so corresponding to this, so for every frame there is a stack trace element. Okay, let's see what exactly happens now. Okay, so maybe at some point here in the method m2, at one point here, it says, let me create an object of some throwable class or a subclass of throwable. So when it calls that, right, when it is calling the constructor of any subclass of throwable, we understand throwable constructor will always be called. Superclass constructors are always used. So when it executes the constructor of throwable, okay, the constructor is calling the method called fill in stack trace. Okay, so when this fill in stack trace is invoked, the job of fill in stack trace is to take a snapshot of the runtime stack. It just takes the picture, what is there currently in the runtime stack, okay, and creates an array. So if I look at this particular runtime stack, there is main, there is m1, and there is m2. There are 3 things in the runtime stack. Okay, so the size of the array which will be created will be 3. So there will be 3 objects of stack trace element created, and they'll be put in an array. Okay, and what is the information captured? Or those 4 pieces of information which is available in each element of the stack trace element. Each element of the array contains objects of stack trace element. Okay, and so yeah, methods, I'll just put the methods of the stack trace element. Okay, and you understand the stack trace element now? What are the methods? So we have a public method returns string. get method name, the method belongs to the class, and the class has been defined in some Java file, and it is currently executing a line. Okay, so these get methods are available to examine what is currently there in the runtime stack. So see, why will one would create an object of throwable? Because there is some error condition. Only in case of an error condition you are creating object of throwable. So when the error condition has occurred, let me know what is the runtime stack showing, what is there currently in the runtime stack, because that's going to help me to understand why the error is occurring. And you would like to normally examine what's there in the stack at that moment of time, and that's where this get stack trace is useful. Okay, what is fill in stack trace doing? Taking the picture of the runtime stack and setting it up in the throwable object. Okay, fine. So you can think like this, that throwable object has got, okay, so this is the picture of the runtime stack, and now just to understand what is the throwable object having. Okay, so a throwable object, so if I just look at a throwable object, right, so this is some throwable object. Okay, it has got, first thing it has is a message, so there is a string, a reference to a message. Okay, so there'll be a message, and this could be whatever message, it's a string. Okay, fine. The second one is another throwable. Of course, we'll look at this, what is this cause thing, and how this is what is actually exception chaining. So another object of throwable can be there. We'll see what it can be. But the third thing is the important one. Okay, this one is the first and the second, that is the message. Okay, this is a message, and the second one is the cause. Okay, they are initialized from the constructor. The cause may be initialized also with the help of init stack, init cause method, right? But this one, the last one, this is getting initialized, okay, with an array. So this one refers to an array. Okay, array with how many elements? The number of elements in the array will depend on how many things are there in the runtime stack. Oh, in the previous example, fine, when it was method main calling m1, m1 calling m2, in that case, yes, there were three things in the runtime stack. Okay, the first one, oh, that's for the main. The second one, oh, that's for the so the second one is for the m1, and this may be for m2. So it says, okay, I've got these three things. Okay, so three objects of stack trace element, and each object, what does it store? So this says the name of the method is so and so, the class name is this, the file name is this, and line number is this. Okay, anyway, these three are strings, so they would be string objects. Okay, and what is the current line number I'm currently executing? So similar thing for the other two objects. So that's how the picture actually turns out to be. Okay, and so the idea of fill in stack trace, take the snapshot and set up the throwable. In the throwable object, there's a array, there's an array type, fine, there's a private variable for the storing the array. So set up the array, fine, create this array and set it up. Okay, fine. Okay, and just one more thing you can understand. Okay, if I consider this particular thing again, okay, let's say a throwable object is getting created here. What was done? fill-in stack trace was done by the constructor, and therefore the object of throwable created here would have three elements in that array, and 3 elements of type stack trace element. So array with 3 elements will be available, right? The stack trace is with 3. Okay. Now, because it was thrown from here, it was created and then it got thrown from here and it got thrown here, right? So at this moment, when it is in this method M1, okay, M2 has thrown it. It is now the turn of M1, right? Normally, M1 would, it would not, what would happen is it would just immediately be throwing out of the M1 also. But we do have an exception handling mechanism where it is possible for someone to be able to capture this throwable object over here. Okay, so if someone captures that throwable object using the exception handling mechanism, okay, it would be possible for this to invoke the method fill-in stack trace again. So if he says fill-in stack trace again, oh, now how many elements are there in this runtime stack? Oh, there are only 2. That same object of throwable, but it is getting changed. The stack trace element is showing a different picture now. Okay, so someone calls a get stack trace after this point of time will be different. Okay, and then maybe it's possible for it to let it propagate further, but after making some changes, it maybe it lets it propagate further. So that kind of mechanism is also possible. So the idea is fill-in stack trace always called from the constructor, but at any point of time in your exception handler, we haven't discussed the exception handling part, it will be possible for you also to invoke the fill-in stack trace method on that object, okay, if you need it. Okay, normally we don't use it, but yes, it's a public method. That's what is significant here, and it will be possible for someone to reinitialize the stack trace element, the stack trace. We call it a stack trace. Okay, so this is one method called. So we have these the methods, the methods of throwable. And the important methods of throwable. What were the methods? Okay. And so this always called from constructor, but you may like to call it in your exception handler. And so this is a getter method, right? Okay. And the other getter methods were get message and get cause. Okay. So yeah, maybe I'll club the getter methods together. So 3 things which you can get. Okay. Cause is something which you can specify in the constructor. If you have not specified in the constructor, you may use init cause method. If already specified in the constructor, then init cause will not work. Okay, it won't fine. You won't be able to set up you can't change. That's the idea. You can't change. If it was not set, yes, you can set up a new value. That is only if it is null, the init cause will work. It's not like a set method. I want to change the cause here. Right? Message can't be changed. There's no set method for the message. Okay, fine. But stack trace, of course, yes, you can always call the fill-in stack trace method to reinitialize it. It's not that you are setting up to anything, whatever you like. Okay, you're just taking the snapshot of the runtime stack. So anytime, take the snapshot of the runtime stack and keep it in a throwable object. Okay, so that's take the snapshot. Okay, and print stack trace is just for displaying the stack trace. You can show it. Oh, what is the content of the stack trace? And whenever you are actually, whenever your program is terminating because of an error at runtime, you actually this is the method which is getting invoked, and the output which you see is nothing but the output of print stack trace. Okay, and clear. And stack trace element methods, these are the ones. If someone uses the stack trace, yes, these methods are individually available. You can examine them. Okay, so throwable object, fine. Let's look at this exception chaining, and the concept of exception chaining. When clear for the methods of throwable, see whatever constructors of throwable and these methods anyway get inherited, right? These are all public methods and they'll be inherited. Okay, fine. Also, the classes, the subclasses of throwable, which subclasses of throwable? Okay, which are those? The ones which we want to discuss are error, and these are the ones which have been provided for error, exception, and runtime exception. Okay, these have, okay, so all of these and same constructors are repeated here. So whatever constructors we have for throwable, and we had those public constructors which are 4 public constructors. So these constructors again repeat in the class called error, exception, and runtime exception. Okay, and so same constructors are available. So when you create any subclass, so normally yes, if you are creating your own exception class, and there's so many ready-made exception classes, but if you wish to create your own exception class, maybe normally you would subclass from exception or the runtime exception. Okay, you don't subclass from error. Okay, errors are for what are the error classes for? Okay, so they are the JVM related failures, exceptions. Okay, so error conditions related to JVM. Okay, and these two are normally the other kinds of errors. Okay, okay, which may require handling, exception handling. Okay, so most of error, these are the normal exceptions of the application. Okay, so these are because of some okay, and these would be trivial exceptions. So these are some very trivial exceptions, I'll say. Trivial exceptions like, oh, you are doing a division by 0. Okay, so it's a problem with the one who is using it. Okay, when he didn't use it properly. Okay, whereas this is because actually there are some conditions like this, right? You were trying to open a file, but the file was not existing. Maybe someone has deleted the file. So it's not basically an error, which is the application's own creation, right? With this, the application wants to actually, he would be able to know that, oh, the problem is because of something going wrong in the file system. Okay, whereas this is, oh, it's his error, right? You should have checked that you don't have a 0 there. Okay, when you're making a division. When you're examining an array, you don't go beyond the number of elements in the array. Okay, so such exceptions, they are very trivial exceptions. So those will be part of the runtime exception. Okay, so JVM related exceptions, fine. So exceptions, yes, You categorize them into three. So this is something which you will never be using. Okay, these are normally no one tries to handle them also, right? Whereas this is something which we normally try to handle. Okay, some occasions you might like to handle runtime exceptions. Okay, we understand this is unchecked and this is unchecked. This is the checked one. Okay, fine. So fine. Now I think okay. Let's now proceed to what is the thing about cause. Okay. So for that, let me take a simple example. Okay, I'll just try to. So it's just a theoretical example which I'm taking. Okay, but this will give an insight into what is what is this cause thing, right? We say we have a method called get cause, and while in the constructor someone might use a exception object. Okay, basically there is exception chaining. We call this as, this is referred as exception chaining. Okay, so what is exception chaining? Or when someone use the cause, okay, while creating a throwable object, if you are using a cause, that's exception chaining. Okay, so for this, let's say we consider that we have a class for RDBMS. Okay, I'm just trying to assume we have some class called RDBMS, and that would have a method. Okay, so there is a method where the RDBMS method says, okay, I will have a method, a public method to return. Okay, it returns maybe a array of rows. Okay, we have a class called row, and there might be a array of row which it might return, and there's a method called select. Okay, and maybe a table name is given as a parameter. Okay, or some SQL queries there. Yeah, table name. Let me use table name. Okay, so there will be some such method which would have been returned here. Okay, fine. What will it involve? Well, what will this method involve? Okay, so this method would involve that it must be examining. So yeah, there will be a lot of coding here. Okay, but at some point it will say, oh, it will have to find out in which file the data has been stored. Maybe this RDBM is using a multiple files, or this table name, maybe it is stored in a particular file. Okay, so okay, so files maybe depending on what kind of RDBMS, they use a table space, and corresponding table space there is a file. So physical file will be there, and somewhere in that file, so first thing it has examined and found that there is some file. So it has found that there is a file, and therefore what it might do is it might say, okay, I have to use the file system. Okay, so I'll create an object of file system. Or rather than file system, I'll use another class. Maybe it has declared a class called operating system. It's with the operating system which is managing all the files, right? So it has OS equals new, and it will create an object of OS. Okay, so whatever is necessary it would have used. Okay, and then it says, okay, now I want to read that file from the OS. Okay, it says, okay, so I have a method to return a byte array. Byte array, bytes equals os.read file, and it says, oh, that's my table name. I have a file name. Yeah. So corresponding to table name, it has first found out the file name. So that was done in this part, right? So it might have done something like string file name, and somehow it has managed. Okay, because of the table, I know what is the file. And then it says, fine, if I have this file name, I'll use the os.read bytes, and then okay, there'll be more code which follows. Okay, so now since it is using a object of OS, let's try to examine what is a class called OS. Okay, in the OS there will be lot many things, okay, which it is taking care of, but fine, it will have a public method to return a byte array. What's that public method? Read file, and takes a string file name as a parameter. And in this read file, okay, it has found out that this file is stored in certain number of sectors on the file system, on the hard disk, right? So this one is knowing that on which hard disk, and which it finds out which are the sectors on the hard disk where this particular file is stored. Okay, so for reading from the hard disk, now it wants to read from the hard disk. Okay, OS would have a mechanism to read sectors from a hard disk. So yes, so for doing that, yes, there is a class called bias equals new bias. Okay, so I'm just trying to give some code like this, and it says, so you got the bias object, and then you can say, okay, I want to read the sectors. Okay, equal to bias dot read sector, or maybe, right? So there is a method like read sector which is available in the bias class. That's what we get. Okay, and then we have the class called bias. And that class would say, okay, you've got a public byte array method, returns byte array, name of the method is read sector, and takes as parameter an integer for the sector number. Fine. Okay, so there is some code which can read the sector and return to you. Okay, so here is some code, but now let's try to assign the throws for each of them. Let's try to examine what kind of error conditions can arise here. Okay, yeah, if I come back to this particular RDBMS, the select method will have a throws. What kind of throws will it have? What should it be throwing? So here it will say, oh, I have a table read. You wanted to read from this table, select from this table, but I have a table read error, exception. So it says, oh, I have a table read exception. That's what I throw. Because you are trying to select from a table, but I can't read from the table, then I'll be throwing a table read exception. And that looks correct here, right? So if someone tries a select on a RDBMS object, gives it a table, it'll say, oh, this table, I have a read problem with this. Okay. So there is a table read exception, a table can't be read. Okay. What kind of throws will this have? Throws file read exception. Right? And what kind of throws will this have? It says, oh, I have a throws for, it will have so many different kinds of throws. One of those could be saying CRC exception. I get a CRC exception. Okay. You can see that at different, these classes are at a different layer altogether, right? RDBMS is an application layer, OS is a lower layer, and BIOS is at a still lower layer, very closer to the hardware. Okay. And see, when we have different layers, the kind of method, each layer is providing its own set of operations, own set of methods, and each method should have its own appropriate error conditions. Okay, the throws is representing the error condition. So someone who anyone who is using the bias should be familiar with what is CRC exception. But that's not the case for someone who is just using the OS. The RDBMS, when he is using OS, he won't be familiar with the something like CRC exception. He will think, oh, what is this kind of a thing called CRC exception? So each layer, right, each method plans its own exception condition, right? See, we can see this, whatever exception in the throws we have written is appropriate for that particular method only. It won't be appropriate for OS to say, I'm going to throw a CRC exception. Or just think if the RDBMS says, I'm going to be throwing a CRC exception. So that's not something which is desirable. Okay. So one thing what is desirable is that every method, depending on where, in which class it is defined, and every method should have its own appropriate throws, which is appropriate for that particular class. Okay. This can't be saying that I'm going to throw a CRC exception. Okay. So what is normally going to be happening is something like this. So we don't disturb the throws because, oh, I'm going to use something. I don't disturb the throws, but rather, okay, the place where I'm doing a read, okay, I will be putting it in some kind of a code where I can handle this, okay, and I should be able to, okay, I'll have to put that code maybe, okay. Try to execute this, and if you catch a CRC exception, okay, in that case, no, I can't be allowing the CRC exception to be thrown from, oh sorry, this has to throw, what will it catch? It will catch the file read exception. So if there is a file read exception, right, I won't throw the file read exception for someone who is using the select method, okay, but I will say I want to throw a new but when I create this object, I will be passing exception as one of the parameters. You will have a message, maybe you will keep a message, right, some message will be there, but you will include this in the constructor. Okay. But the reason why this table read exception occurred was because I got a file read exception. Sorry, this is file read exception. I'm just trying to. And what is this? What's going to happen here? It says I want to handle the CRC exception. And when the CRC exception occurs, I'm going to throw new. What is it that I throw? I will be throwing the file read exception. Okay, I will have the message, and the reason for file read exception is the CRC exception. Okay, so the reason, that's the cause. What we call as cause is nothing but the reason. Yeah, here what he is doing, he is just saying, oh, there was a problem. Calculate the CRC. The CRCs don't match. Okay, so CRC doesn't compute correctly, and therefore I will have to say, so for some, if CRC if CRC is not consistent, if it doesn't compute correctly, then I'll be throwing okay, and would have its own constructor, whatever it wants, a message or whatever it wants to do. right? So this is something, this is how the exception chaining is happening. You can see what is happening here. Right? A method at a lower level will throw a particular kind of exception. The higher level method, it can't come out of it because it can't read the sector. Obviously, the reading of a file would fail because the reading of sector failed. It can't be a success scenario here. Okay, it can't return a byte array. It will say, I can't return you the byte array. I'll be throwing you a file read exception. But for this file read exception, the cause was the CRC exception. Okay. Same way, if you look at this select method, it says, I couldn't read the file, and because I can't read the file, how can I create the rows for you? I can't create the rows, and therefore I will be throwing a table read exception. There was a problem reading the table. Okay, but the cause for the table read error was the file read exception. So table read exception because of file read exception. So the cause is there always, right? So we have, see, this is happening because a different exception is to be thrown, and we don't want to throw the same exception. Okay, I'll try to relate it with the real world example of, if you can recollect what we had done on the day one. Okay, fine. On day one, I showed one example, a real world example, where we wanted to check with the if you recollect, I'll just recollect what that example was, the real world example which we had taken. We had something like this, that the problem was in the real world was to send flowers to a friend, right? Okay, who was in Kolkata. So what we did from Baroda, what we did was, we said, we went to JK Florist. So we have an object of JK Florist, right? This was the JK Florist object. Okay, our interaction with JK Florist, like, oh, we were invoking the method called send flowers. Okay, and we gave him, what was the information we gave? We gave him the type of flowers, the quantity, and name and address. So we said, this is the name and address, this is the quantity, and that's a type of flowers, right? So we said, okay, send flowers, right? And what he did, he examined a diary, and then he located in Kolkata, there is someone called KK Florist. So he interacts with the KK Florist and says, send flowers again. Okay, and he says, send flowers again, giving the same piece of information. What this KK Florist did was, what did he do? He used a flower producer first. So there was the object of the flower producer with whom the interaction was, get me the flowers. Okay, it says get flowers, and he gives me, he gives the name and address, not name and address, the type of flowers and the quantity, only two things. He gets the flowers. Once he got the flowers, what he did was he interacts with the delivery boy, okay, and he says deliver. Okay, when he says deliver, he gives the names and address and the flowers which he had got from the flower producer. Now this delivery boy, he looks at the address, he finds there is a street, okay, and there's a house number on that street. Okay, so when he goes to there, he doesn't find that such a house exists. If the delivery boy doesn't find a house with that house number, whatever is mentioned in the address, what will the delivery boy do? Is this deliver successful? Is this deliver method successful? No. If it was successful, what he would have done, what the delivery boy would have done if it was successful, he would have taken an acknowledgement, right, and returned the acknowledgement to the KK florist. Okay, so there is a simple acknowledgement slip which he'll get it signed, and then he'll return. Okay, I've got this acknowledgement, I've done my task, so I have successfully completed the deliver. That's what the delivery boy is supposed to do. So the deliver method is nothing but it is about going to that locating the person, and giving it to him, getting a signature on the on an acknowledgement slip, and returning that acknowledgement, return the acknowledgement to the one who has asked him to deliver. Okay, so that's the whole process involved in deliver, right? So one thing what can happen here is, he won't be able, now in this case, he won't be able to give an acknowledgement slip. What will he be doing? What does deliver do then? He throws a memo, right? He will have a memo slip. Okay, this is a wrong address, right? It's not a normal acknowledgement now. This is an error condition. Okay, fine. So there is a slip which he has to where he will put the information, and then he will send it back. He will throw it to the KK florist. What will KK florist do with this slip? Yeah, what will KK florist do with this slip? Who invoked send flowers? JK florist has invoked the send flowers, right? Here is our JK florist. This is JK florist. Yeah. So what will he do now? KK florist. He found it's an error condition now. So send flowers here can't be successful, right? This send flowers which is over here is not going to be successful now, because the deliver is not successful. This is also not successful. How the delivery boy changed? What did the delivery boy do? He has thrown a memo. Okay, he's not returning now, he's throwing. It's an error condition. Okay, so he's thrown a memo. There's an error condition. It's not successful, this is failing. Okay, so what will this KK florist do when he receives when a memo is thrown at him? One option here is, okay, he'll throw the same memo back to JK florist, and then JK florist will throw it back to you, right? But another option which normally would be taken here is, because you know what has happened here, the delivery boy is a local guy, he's a Bengali guy, and the memo slip is written in Bengali. Okay, something which you are not ever going to figure out what he has done. Okay. Right? So what will be done by the KK florist when he receives a memo? When a memo is thrown from the delivery boy to the KK florist will create his own another memo. Okay, fine. He'll prepare a memo, fine, which will be in English rather than being in Bengali. Okay, it will be in English. Okay, so that you can understand. Okay, not you, rather it's something which the JK florist should be able to understand. Okay, fine. But when he is preparing the memo, he must attach a proof to it. Oh, what is the proof for this? Right? It's not just like that. He's saying, oh, so as a proof, he says, oh, I have this memo from the delivery boy. So I'm attaching the memo of the delivery boy when I'm preparing my memo. So I prepare my own memo. I don't use the same memo. So what is being thrown from in the send flowers method over here, what is being thrown is not the same error as what was thrown by the deliver method. He is creating his own error condition, but when he's creating an error object, right, the exception object, okay, so this send flowers, when he's throwing from here, it is throwing a different object than what was thrown by that. But that other object which was thrown by the delivery boy is kept as an attachment. Okay, and then of course when JK florist receives, he is again going to do the same thing. That is, he'll prepare his own new memo and says, okay, I have got those two memos along with this. Okay, so that's what will be thrown back to you. Okay, so it's not you are getting the directly only the exception object which is thrown by the delivery boy. Okay, and so this is nothing but chain, right? So we have the object of exception being created here again, a new one. Okay, to which is attached the one which is created by the, so this is from JK Florist, created by JK Florist. This is, there is one where he says, oh, this is because I received this from the KK Florist, and the KK Florist is the one who is saying, oh, I received this from the delivery boy. Okay, so something created by delivery boy is attached, is an attachment to what is thrown by KK Florist. So this is basically the concept of exception chaining. Okay, it's a chain of exceptions. So we call it as a cause. Yeah, this exception because of another exception, this exception because of another exception. Fine, clear on this exception chaining? Okay. Yeah, any questions? Okay, fine. So then we proceed, right? Okay. So next what we can look at is, we'll look at how do we create our own exception class. Let's create a custom exception class of our own, and especially we want that exception class to be there in our account class. So let's try to update our account class, okay, so that it can, if someone gives a negative value, maybe in the constructor he is giving negative value for the opening balance, or in any of the deposit or withdraw, if someone is giving a negative value for the amount to be deposited or withdrawn, fine, we won't accept that. Fine, we'll say, oh, this cannot work. Fine, we want to fail that operation. Okay, even you can't create account object right with the beginning with the negative value for the balance. Okay, and so if you want that, yes, we would be creating a we need to have a exception class whose object would be created. Okay, fine. So let's see what we can do for this now. Okay, how do we go about creating our own exception? Okay, so we want to create our own exception class. There are so many ready-made exception classes which are there in the Java library. Okay, and some okay, but I think before going to these exception class, let me mention some very common. Okay, so let's have, okay, I'll just mention the common or the trivial exceptions which are. Okay, so what are the trivial exception classes? These are all subclasses. So one is the arithmetic exception. Okay, it's a subclass of the runtime exception. When does it happen? Okay, fine. Then another one is array index out of bounds exception. So these are whatever I'm giving, they are all the unchecked exceptions. Okay, these are the unchecked exceptions. Yeah, so array index out of bounds exceptions. Fine, you have used array index array index, for example, a of I when I'm saying, right? Okay. When you are using a of I, okay, where I is not in what is the range? 0 to a dot length minus 1. Okay, so if it is not in the correct range, yeah, that would be array index out of bounds exception. Okay, what other exceptions are very trivial? Okay, right. Trying to evoke method or right? Trying to, rather than invoke, trying to access member on null. Okay. Right. For example, you might say a dot toString okay, something like that. Okay, so null pointer exception. Then okay, another one, we haven't examined actually some of the methods, but there is a mechanism where, so let me show you some methods. I think first we have these classes called suppose I've taken an string as an input, right, and I want to convert it into a int type. See, I got something like this. So this is a string. Okay, I have a string like this, but I want it as an int. So this is string. Okay, so you got a string like this. It is made up of all digits only, and someone says, I want an int value for this. Int I equals. How do I convert it into a string? From a string, how do I get an int value? So for that, we normally use a method called integer dot parse int. Okay, yes. So this is how you convert a string to int. So this one here, okay, would give an error in case, okay, if I just take this something like this, if it was having something like this, right? So maybe someone says a or something like this. Okay, so this would be throwing a exception. This will be number format exception. Okay, so we have various kinds of, so like this, yes, even so we have the number format exception. So for any numeric type, basically, you may be trying to convert a string to a numeric type, okay, where the string and at this moment, yes, that's what I'll write. So we do have such things, right? So so these are some common exceptions, which common runtime exceptions basically. Okay, so these are some exception classes which are commonly found. Okay, Null pointer exception is one of the very common things. Okay, it's a programming error basically. Whenever you are trying to invoke something, you should have actually check if A is an instance of whatever you are trying to have it as. Okay, so instance of check is there, or you can even examine double equal to null, you can say. Okay. Okay, this you remember is one of the most common found errors. Okay, fine. So now I think we can proceed with writing our own custom exception class. Okay. So for the account class, basically the constructor and constructor okay. So constructor and deposit withdraw methods. Okay. Okay. So if any negative value is given, yes, we would like to fill them. It would look something like this. If I look at a constructor, maybe, so the change, the change we want is something like this: public constructor for account. Okay, constructor for account says it would require a string. Okay, it was saying it needs a long for the account number, a string for the name, and another long for the opening balance. Okay. Okay. So if it needs this, fine. Yeah, what can be done here? If opening balance is less than 0, that's the first thing you'll do. Check. And if this is the case, we'll say throw new and some object of a throwable class, so some subclass of throwable. So we want to have our own throwable class and say negative amount exception. Okay, and okay. Maybe just a message. You might just say, oh, let me give just a message here. Okay, or what is that negative amount? If you want to keep that also, we can. So we can add. We can have our own constructors like this. Okay. And similarly with the deposit and withdraw method, and then the other things will continue here. Okay, in the account constructor. So we would like to update our constructor. So the idea is, yes, we would like to have our own exception class, something like this. So how do we define this class? Negative amount exception. Okay, and so let's open this and let's create our own exception class. So what we are doing is creating our own custom exception class in this. So we'll keep it part of the same package. Okay, so we want it to be it's an exception type, right? Extends from So you have this exception class, which is the subclass of throwable. So we want a check. So this will be a checked exception. Okay. Yeah. It can keep a private variable for the negative amount value, right? Whatever is the negative amount. Okay. And it can provide a constructor. The constructor can take two parameters, a string for the message and a long for the amount. Okay. Like a constructor for any other class, okay. It will call the constructor of the superclass first, and there we are passing the message, and we can say this dot amount is equal to empty. Okay, so simple thing. And we have inherited methods from the exception class, and now we can add more method to it, okay, to return the amount. Okay, we are not providing a method where he can change the amount. Okay. So yeah, another thing what you can do here is we can override the toString method. Return. So toString according to the superclass plus I want a colon plus whatever is the amount. So string conversion, yes, we'll go by whatever is the string conversion according to the exception class, and to that we just append colon and give the, or maybe you want to say comma and give yeah, negative amount colon, and what is the negative amount value. Fine. So whatever is in the toString of a string representation for superclass, put a comma and append comma negative amount colon and what is the amount. So we are just adding, because we are adding an instance variable, and since we are adding an instance variable, so we are appending to the toString method of the superclass and to include that information about the current instance variable. Okay, so we have saved it as negative amount exception.java. Okay. Okay, now we can compile this class.